In this video, we'll be talking about the binomial theorems and the Pascal's triangle. You see, binomial expression is the sum or the difference of two terms. For example, x plus 1, 3x plus 2y, a minus b, x minus y, and so on like that. All of them are binomial expression. If you want to raise a binomial expression to a power higher than 2, for example, if you have x plus 1 raised to power 7, it is very cumbersome to do this by repeatedly multiplying x plus 1 by itself. So in this unit, in this particular video, we'll be learning about the triangular pattern of number known as Pascal's triangle and how it can be used to obtain the required result very quickly. In order to master the techniques that is explained here, it is very vital to undertake plenty of practice exercise so that they can become second nature of you itself. So after watching this video, you should be able to generate Pascal's triangle, expand binomial expression using Pascal's triangle, and using binomial theorem to expand binomial expression. So let us talk about the binomial expression itself first. Like I said binomial expression is the sum or difference of two terms. For example, the one that I have here, x plus 1, 3x plus 2, a minus b, and so on. We are familiar with it already, actually, like expanding a bracket such as x plus 1 raised to power 2. We know that it is equals to x plus 1, right? So if you multiply this one by this one, we have x squared plus plus what? Plus 2x plus 1. We know that we have this already, and that is how we are always doing it. But if you have something like x plus 1 raised to power of 7, we all know that what is going to happen? It is going to be, we are going to be saying x plus 1 multiplied by 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 x plus 1 multiply by x plus 1, and so on and so forth. And this is very cumbersome. It won't be easy to be continuing this thing in repeatedly pattern. There will be mistake. So we require to get a very fast result. Therefore, we are going to require something we call the Pascal's triangle. Now, let us start generating the Pascal's triangle. How are we going to generate it? You see, a Pascal's triangle is a triangle that starts, or every side of this triangle starts with the figure 1. You understand? This is how a triangle looks like. This is how a triangle looks like. So that's exactly how this triangle is going to look at, but it is a triangle of numbers. You understand? So it starts with 1. You understand? This is just 1. Are you getting me now? Now the next one is now 1 1. Are you getting me? Now the next one, so the first one is having what? Is having a value, or is having only one value. The second one is having one value, two values rather, like two values. Therefore, the third one is going to have what? Is going to have three values. Are you getting me now? It's going to have three values. Now, what are we going to do to that one? Now, we are going to say the next one will still have 1 1. Now, how are we going to get the middle number that is here? Very easy. You just say 1 that is here plus the 1 that is here. You are going to get the middle value. Now, 1 plus 1, 1 plus 1 will give us what? Will give us 2. Therefore, the middle value in this one is 2. Are you getting me now? Now, sorry, I mean this one plus this one here. This one plus this one here will give us the 2 that will be here. You understand? Now, this one has given us 2. The next one is, remember I told you it always starts with what? It always starts with 1 1. Are you getting me now? Now, the next one will now be what? Will be to get the two values that is there. Remember, the fourth value is going to have, and the fourth this thing on the Pascal's triangle is going to have what? It's going to have 4 values. Just like this one has 1 value, this one has 2 values, this one has 3 values, this one must have what? Must have 4 values, which means we already have 2 values already. We already have 1 here, we already have 1 here. Remaining 2. How are we going to get the remaining 2 that is here? Very easy. We just say 1 plus 2. The 1 that is here plus this 2 that is here will now be equals to what? Will now be equals to 3. Therefore, 1 plus 2 will also give us 3. So that is 1 3 3 1. I get me now. Now, let us go to the next one. That one will also have 1 1. You understand? Now, how do we get the remaining 3 values that will be here? It will be 1, 3 plus 1 will give us what? Will give us 4. 3 plus 3 will give us what? Will give us 6. 3 plus 1 will give us 4. Therefore, we are complete. And that is how we continue. That is how we continue. Therefore, the next one will be what? Will be 1, 1. We are starting with 1, 1. Remember, now 1 plus 4 will give us what? Will give us 5. 6 plus 4 will give us what? Will give us 10. 6 plus 4 will give us what? Will give us 10. 4 plus 1 will give us what? Will give us 5. And that is how you are going to build a Pascal's triangle. That is how Pascal's triangle is being built. You understand? So, which means if I want to summarize the Pascal's triangle, I'll be having 1, 1, 1. Sorry, 1, 1. 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 5, 10, 10. 5, 1. 1, 6, 15, 20, 15, 6, 1. Can you see the way it looks like? Look at the shape that it gives. It gives a what? It gives a triangular shape. That is why it is called what? That's why it is called Pascal's triangle, because it is actually developed by a man called Blaise Pascal. You understand? Now, how are we going to apply this? How is this being applied? Now, you see this one, it is when it is raised to the power of 0. This one is when it is raised to the power of 1. This one is when it is raised to the power of 2. This one raised to the power of 3. This one raised to the power of 4. This one raised to the power of 5, and so on and so forth like that. Now, let us take for an example. The first one that we did the other time, x plus 1, for example. Or, no, don't let us do x plus 1 yet. Let us do a very simple form, which is a plus b raised to power of 2. We are now asked to expand this. Remember, raised to power of 2, which means what are we going to do? We are going to be using this particular one that is here, which is 1, 2, 1. Are you getting me now? Now, very, very easy. What you're just going to do is that what? It will be equals to. Now, how are we going to do the power? You see, everything in this Pascal's triangle, they are what? They are coefficients. They are what? They are coefficients. So how you are going to do the power is that the first one that is here is going to be taking the highest power, while the second one that is here will be taking the lowest power. Now, in this particular case, you will notice that the highest power will be 2, you understand? And the lowest power will be what? Will be 0. So we are going to have a raised power 2, b raised power of 0, you understand? Because the lowest power is 0 and the highest power is 2. So the first expression in this, if you want to expand this, the first one that is here will be taking the highest power, and the second one that is here will be taking the what? The lowest power, which is 0. Now let us quickly do that. Now, which means we are going to be having what? We are going to take the first coefficient, which is 1. That will be 1. You understand? Therefore, we are going to have a raised power of the highest power, which is raised power of 2. Therefore, b raised power of lowest power, which is raised power of 0. That will be our first one. Now, the second one will be plus. You understand? That will be plus. Now, the next one is we are going to take what? We are going to take this particular expression, which is what? Which is 2, the one that is in the middle. I'm going to write 2. Now, what is going to be happening is that you see this a will be decreasing by what? It will be decreasing by the fact by 1. You understand? And this b will be increasing by 1. Now, if this a decrease by 1, if the power of a decrease by 1, what will it be? To become a raised power what? A raised power 1. And if this one increase by 1, it will be what? It will be b raised power 1. You understand? Plus. Now, the next one is what? That is the third coefficient, which is 1. That is 1. Therefore, we are going to be having what? We are going to be having a. If this one decrease by the value of 1, it will become what? It will become 0. If this one increase by 1, it will become what? It will become 2. That is b raised power of 2. Therefore, we'll be having what? We'll be having something like, we'll be having something like, now that will be equals to, you know that 1 multiplied by everything is the same thing. That is a raised power 2, b raised power 0, plus 2ab plus a raised power of 0, b raised power of 2. But we know that anything raised power 0 equals to what? It equals to 1, which means this one is not necessary there. This one too is not necessary here. Therefore, my answer equals to a squared plus 2ab plus b squared. And this is how to use Pascal's triangle for what? For expansion. You understand? Let us take for another example. Let's say we have a plus b raised to power of 3. A plus b raised to power of 3. How are we going to do this? Remember the Pascal's triangle that we have. The Pascal's triangle, which means since it is raised to power of 3, we are going to be using the one that is here, which is 1, 3, 3, 1. So I can write it somewhere that I'm using 1, 3, 3, 1. That is what I'm using. Now, the first thing you're going to do is what? Take the first coefficient. What is the first coefficient? That is 1. Right? Remember, I told you the A is going to take the highest power. That is A raised to the power of 3. And B is going to take the lowest power. That's B raised to the power of 0. Plus, therefore, you're going to take the second coefficient. That is 3. Now, the A is going to be decreasing by 1. It becomes what? A raised to the power of 2. And the B is going to be increasing by 1. That is B raised to the power of 1. You understand? Plus, therefore, the 3 again. Now, that will be 3. Now, A is going to decrease by 1. That is A raised to the power of 1. And B is going to increase by 1. That is B raised to the power of 2. Plus, now the next thing is 1, right? That is 1. Remember that A is going to decrease by the 1 by power of 1. That is A raised to the power of 0. And B raised to the power of what? B raised to the power of 3. And that will be equals to what? That is going to give us, remember, anything raised to the power of 0 equals to 1. And 1 multiplied by everything is the same thing. So we're having A raised to the power of 3 plus 3A squared B plus 3AB squared plus B raised to the power of 3, right? And this is out. Can you see it is very, very easy using Pascal's triangle in expanding. Instead of doing what? Instead of doing A plus B into bracket A plus B into bracket A plus B, then you now use this one to open this one first. Whatever you now get, you now still use it to open this one, which means this Pascal's triangle makes it very, very easy. You understand? And you can actually try this one out. You can do A plus B raised to the power of 4. You understand? Now, let us do a particular question here. Let us say we have question like 2x plus y raised to the power of 3. Now, what you have to understand that you see this 2x that is here, all of them represent what? Represent A. You understand? All of them represent A, which means these two, whatever the power of that 2 has, x also has it. You understand? And since it is raised to the power of 3, therefore we are using the 1, 3, 3, 1. And that will be equals to what? That will be equals to, I'm taking 1 first. So I'm taking 1, that is 1. Right? Now, you know it is like A is going to take what? Is going to take the highest power. That is, you have to open a bracket, 2x raised to the power of 3, add y raised to the power of 0, plus the next one is 3. That is 3 raised into bracket 2x raised to the power of what? Raised to the power of 2, y raised to the power of 1, plus 3, another 3, that is 2x raised to the power of 1, y raised to the power of 2, plus the next one will now be what? The next one will be equals to 1, 2x raised to the power of 0, y raised to the power of what? Raised to the power of 3. Right? Now, remember it is 1, 3, 3, 1. We are using 1, 3. So if you can see very well, we have 1, 3, 3, 1. You're just going to add everything together. Now let us start solving it one by one. Now the first one is, remember the first one is what? The first one is 1, 2x raised to the power of 3, y raised to the power of 0, right? Y raised to the power of 0 equals to 1. And 1 multiplied by everything is the same thing. So I'm only left with 2x raised to the power of 3. Now 2x raised to the power of 3 will give us what is the same thing as 2 raised to the power of 3, 2 raised to the power of 3, x raised to the power of 3. It's the same thing. You understand? Remember I told you that whatever 2 owns, x also owns it since the both of them are A. Now 2 raised to the power of 3 is equal to what? Equals to 8. That which means that one will give us what? Will give us equals to 8x raised to the power of 3 plus the next one is what? Is, look at it. Now it will now be what? You know it is 2x raised to the power of 2. It is everything here that owns it. That will be 2 raised to the power of 2 x raised to the power 2, and that will give us what? That will give us 4x raised to the power of 2, which means in this case we're having what? Plus 3 multiplied by 4x raised to the power of 2, then y. You understand? Y raised to the power 1 because of the 3 that is here. We have not used that 3 yet. The next one is now 2x raised to the power 1 equals to 2x, right? That will be equals to what? Plus 3 times 2x and what? And y squared plus 1, that is 1, times, that because what? 2x power 0 equals to 0, equals to 1 rather. Therefore, we are left with what? We are left with y cubed. And this is going to give us what? This is going to give us 8x raised to the power 3 plus that will be equals to 12x squared y plus this is going to give us what? 6x y squared plus y raised to the power of what? Y raised to the power of 3. And can you see? This is how to use Pascal's triangle in expanding what? In expanding mathematical expression. Are you getting me now? Now, let us take for an example. You have a question like, let us say you have a question like, expand 1 plus 2 divided by x, everything raised to the power of what? Raised to the power of 3. How are you going to do it? Since it is raised to the power of 3, therefore I'm going to use the Pascal's coefficient, which is 1331. Or let me just use raised to the power of 2 in this case. Or let me use raised to the power of 3. So I'm going to use the Pascal's coefficient 1331 again. So I'm using 1331. You understand? Or should I use 14641? Let me use 4. Let me say raised to the power of 4. You understand? That'll be what? 14641. Very, very easy. What am I just going to do? Remember, I told you this one will take the highest power and this one will take the lowest power at first. So that will be equals to what? That will be equals to 1 multiplied by 1 raised to the power of 4 and what? And multiply by 2 divided by x. Everything is power what? Everything is power of 0, right? Plus the next one is what? 4, right? 14641. It will be 4 multiplied by 1 raised to the power 3, then 2 over x raised to the power what? Raised to the power 1 plus the next one is 6. That will be 6 multiplied by 1 raised to the power 2, right? That's 2 divided by what? Divided by x raised to the power what? Raised to the power 2. Therefore, the next one is plus 641. That is 4 multiplied by 1 raised to the power 1, right? Upon 2 divided by x raised to the power 3 plus the next one will be what? 1. The remaining one that is here, that will be 1 multiplied by 1 raised to the power 0 into bracket 2 divided by x raised to the power what? Raised to the power 4. And then we have our this thing here. Now remember that this one that is here will be equals to what? Will be equals to 1. And 1 raised to the power 4 equals to 1. Therefore, our answer here will be equals to 1 plus the next one is 4 multiplied by 1 raised to the power 3 equals to what? Equals to 4, right? 2 raised to the power 1 equals to 1. Therefore, 4 times 2 equals to what? 4 times 2 equals to 4 divided by x. So that will give us 4 over x. The next one here is what? 6 multiplied by 1 equals to 6, right? 2 raised to the power 2 equals to what? Equals to 4. X raised to the power 2 equals to x squared, right? So it's same thing as 6 multiplied by 4 divided by what? Divided by x squared. And 6 times 4 equals to what? Equals to 24. And that is going to give us what? Plus 24 divided by what? Divided by x squared. Plus the next one is 4. Now this is 2 raised to the power 3, right? 2 raised to the power 3 equals to 8. X raised to the power 3 equals to what? X raised to the power 3 equals to x raised to the power 3 equals to x raised to the power 3, right? And that was the same thing as what? That's the same thing as 4 multiplied by 8 divided by x raised to the power 3. And 8 times 4 equals to what? 8 times 4 equals to 32. Therefore, that's equals to what? That equals to 32 divided by x raised to the power 3. Plus the next one is what? 2 raised to the power 4. That's equals to 16. X raised to the power 4. That will give us what? 16 divided by what? Divided by x raised to the power 4. And this is my answer for this particular Pascal's expansion. Can you see how to use Pascal's triangle for what? For expanding this thing now. Very, very easy. Like a very, very easy aspect of mathematics. So I hope you understand this, and I'll be giving some questions for you to solve. Let's see, 1 plus 3x squared, 2 plus x raised to the power 3. This is question number 1. Question number 2. Question number 3. 1 minus x raised to the power 3. Question number 4. 1 minus 5x raised to the power of what? Raised to the power of 5. Question number 5. X plus 6 raised to the power 3. Yes. So these are the questions I'll be giving you. Thank you and God bless.